Welcome back to Pace AI's foundational AI course for educators. My name is Joe Marquez, and I have the pleasure of guiding you through lesson 2 of this course. Today's lesson is on what is machine learning. In fact, how do machines learn at all? And how do machines take this information they have learned to create something as an output? That is what we are going to be helping you learn today. And we're going to learn about this through blueberry muffins and cute cuddly chihuahuas. Now, you may be asking, Joe, how are we going to learn about machine learning through these great bakery treats and these really tiny teacup puppies? Well, take a look at this image. If you look at this, you can decide, well, the one in the upper right-hand corner is absolutely a delicious blueberry mutton, and the one in the upper right-hand corner is, of course, a cute, cuddly chihuahua. But that is because we have learned this over time. Now, how does a machine learn this? How does a machine decide what a blueberry muffin is versus what a cute, cuddly chihuahua is? You see, this is done by massive amounts of data. Thousands, hundreds of thousands, millions of images being fed to these machines and labeled, this is a blueberry muffin, and this is a chihuahua. And through these images and labels, it begins to learn what attributes to the characteristics of a muffin and what attributes to the characteristics of a cute, cuddly chihuahua. And through this, the machine can learn to tell you the difference between the two. But how does this work? How does something such as a question of, is this a chihuahua or a blueberry muffin? What happens for the machine to actually give the answer of, yes, that's a blueberry muffin, or yes, that is a cute, cuddly chihuahua? How does this actually work? Well, for me to tell you, I have to show you this image. The image off to the left is an actual image off of a paper of how machine learning works. And you see at the very top of this image, we have what's called the input layer. This is where you put your question or your image. We call that the prompt. And this is what you give the machine. Something as simple as, is this a chihuahua? Right? And that could be an image of either a blueberry muffin or a chihuahua. And as it goes through these layers, it's like when something goes through the neurons of your brain. You see, outwardly, all the senses coming into you, your sight, your hearing, the sense of smell, all of these things are being fed as inputs to your brain, and your brain has to make sense of it through the neuron pathways in your brain. That is how these machines work. Every layer is like going through a neural pathway, making a decision of which other neuron it should hit until it finally comes out with an answer, with an output. That is how these devices work. But that can be a little bit complicated and a little bit overwhelming. So I like to explain this with the simple game of Plinko. If you're like me, when you were younger, you used to love watching The Price is Right on days off from school. But my host was Bob Barker. But one of my favorite games was Plinko. And you see, I loved this game because every contestant at the top felt like they had control of the board. If you've never seen this game, they take a small disc and they get to place it anywhere at the top of that board. They get to make the decision of where they want that chip to be input into the Plinko board. But as soon as they let go, they relinquish all control. It is completely up to the layer and the peg that it hits. And when it hits the peg, it goes off at a different angle and then hits another peg and then another peg and then another peg. You, the contestant, do not have control until it finally reaches an output layer. And the hope is that it hits the 10,000, but that's not always going to be the case. And contrary to your belief, the contestant has no control over where it lands. That is how machine learning works. You see, if we have an image of a Chihuahua as our input, and we are asking these machines, is this an image of a Chihuahua? It doesn't have eyes, but it does have the data of thousands of images of Chihuahua in its data set, and thousands of images of blueberry muffins in its data set. And based upon being fed all of that data, it goes through each individual layer, looking at criteria to decide, is this an image of a Chihuahua? To where it finally comes out and says, yes, this is an image of a Chihuahua. That's what these hidden layers do. Sometimes you will hear this referred to as the black box, because even though we can tell you how this was created, there is still investigations underway of how it actually works here in the hidden layers. It is both fascinating and frightening, all at the same time. But for a machine to learn that this is an image of a Chihuahua is absolutely amazing. So, how is machine learning achieved? And we've learned this. It's through massive amounts of data being fed from a data set into these tools so that it can go through different layers, just like on the Plinko board, to decide what the output should be. And the output is completely going to be dependent upon what is the machine supposed to do. For example, self-driving cars, right? They are based on machine learning because they have been fed massive amounts of data on what people look like. So avoid them, right? What's a shadow? So you're not jerking out of the way of a shadow because you think it's a person. What does another car look like? What is a safe distance away? What are these lines in the middle of a road so it knows what side to stay on? All this massive amount of data helps the car to make decisions. The input would be the images being fed from the camera at the very top of the car, and the output would be the decision the car makes based upon the data it has been given. You can also see this in action with Pace AI grading of student pronunciation. You see, by understanding correct enunciations of words, Pace AI can help students understand whether they said that correctly or incorrectly and then guide them towards the correct path. That would be the output. But again, that is based on massive amounts of data that Pace AI has to have its machine learn how to give the proper feedback to the student. And now we also have machine learning for health, to help us diagnose diseases, to help us identify new forms of proteins. We are in an amazing time where machines can utilize the data collected by humans to make predictions of what to do next. We are just at the forefront of what these technologies can do. They are not going away. They're only going to get more powerful. That's why it is up to us as educators to learn how to harness the power of machine learning, to learn how to harness the power in these tools that are being shown to us as educators to make better lessons for our students and to make a better experience in the learning process for our students. You see, once we understand how these machines are made, we can better make decisions on how we want to implement them during the learning process. But the great thing about it is that you, the teacher, get to make the decisions of how to use it with your students. And that, my friends, is the most amazing part that we have with these new technologies. Thank you so much for joining us for Lesson 2. Please join us for Lesson 3. And thank you so much for joining us for Pace AI's Foundational AI course for educators.